Hello students and welcome back to the next module of our 3D lines chapter. Now in this module students we will try to solve some problems on the theory that we learned in previous module, that is perpendicular distance of a point from a line. Let us start with the first one. First question says find length of perpendicular from 2, minus 3, 1 to the line r bar is equal to minus I cap plus 3j cap minus 2k cap plus lambda times 2I cap plus 3j cap minus k cap. So we are given a point outside the line and we are given a line. We need the perpendicular distance. Let us start immediately. We say given line is, we copy the same line from the question. Now students, if we compare this line with our standard equation, that is r bar equals to a bar plus tb bar, we say, right? Here we take it lambda b bar. We get a bar and b bar, that is a bar equals to minus I cap plus 3j cap minus 2k cap and b bar is 2I cap plus 3j cap minus k cap. Now as we know, we require these values in our formula. So let us proceed. Now, by taking these values, we say that given point outside the line is alpha bar and that is given as 2I cap minus 3j cap plus k cap. And once we get alpha bar, a bar and b bar, we are ready to go for the formula. Right students? So we say perpendicular distance is given by, as you can see in the diagram, it is Pm equals to square root of alpha bar minus a bar the whole square minus alpha bar minus a bar dot b bar upon mod of b bar the whole square. Now students, we cannot or we will take some time to calculate directly. So we solve this type of problem in parts. We calculate the first part here. The first part is magnitude of alpha bar minus a bar. That becomes magnitude of 3I cap minus 6j cap plus 3k cap. And it is square root of 3 square plus minus 6 square plus 3 square. And this gives answer as root of 9 plus 36 plus 9 and this becomes square root of 54. So the first part we got. Let us go for the second one. Second part says alpha bar minus a bar dot b bar upon mod of b bar. Let us calculate this one. It gives us 3I cap minus 6j cap plus 3k cap dot 2I cap plus 3j cap minus k cap divided by mod of 2I cap plus 3j cap minus k cap. On numerator and denominator, on simplification, we get 3 into 2 plus minus 6 into 3 plus 3 into minus 1 divided by root of 2 square plus 3 square plus minus 1 square. And now students, we get this as 6 minus 18 minus 3 divided by root 14. It becomes minus 15 upon root 14. So once we have two parts ready, let us proceed for the final step. The final step says Pm is equal to square root of 54 square minus 15 upon root 14 the whole square. And this becomes square root of 54 minus 225 upon 14, which gives us 756 minus 225 upon 14. And students, the distance required is square root of 531 upon 14 units. Alright, so this is how we calculate perpendicular distance. Let us proceed. Question number 2 says find the foot of perpendicular from the point 0 to 3 on the line x plus 3 upon 5 equal to y minus 1 upon 2 equals to z plus 4 upon 3. Also find length of perpendicular. So we need foot of perpendicular and length of perpendicular. Let us proceed. Let M be the foot of perpendicular drawn from point P to the given line. So here is the diagram. P is given and line Cartesian form is given. So the coordinates of any point on this given line students is obtained as, how do we obtain coordinates? We take the same expression again and we assume this equation of line as some constant, let us say lambda. And once we assume this as lambda, we can calculate x, y, z, right? So we say let M, that is foot of perpendicular, as x, y, z, which is 5 lambda minus 3, 2 lambda plus 1 and 3 lambda minus 4. So once we get foot of perpendicular, let us call this statement 1. Now direction ratios of given line are A1 is 5, B1 is 2 and C1 is 3. Now students, direction ratios of PM we have P and M values. So direction ratios are A2 is 5 lambda minus 3 minus 0, B2 is 2 lambda plus 1 minus 2, and C2 is 3 lambda minus 4 minus 3. And they become A2 is 5 lambda minus 3, B2 is 2 lambda minus 1, and C2 is 3 lambda minus 7. Now once we have these values, we know that when two lines are perpendicular, as PM is perpendicular to line, A1 A2 plus B1 B2 plus C1 C2 is 0. This gives this simplified expression which becomes lambda is equal to 1. So by solving we get lambda is 1, students. Now by putting lambda is 1 in equation 1, we get M as 2, 3 minus 1. Right? So let us find length of perpendicular from P on the given line. So once we get M, we have P. As you can see in the diagram, we can directly go for distance formula to find PM. So we have P and M. The distance will be 2 minus 0 whole square plus 3 minus 2 whole square plus minus 1 minus 3 whole square under root. And on simplification, students, we get distance PM as square root of 21 units. Alright. So here we calculated some problems on distance of a point from a line. Thank you.